So hello guys, welcome back to my channel called Shiva, where I'll be posting DSA or leetcode solutions each and every day. And today is day 9th of doing so. The problem that we'll be solving today is a majority element, which is leetcode problem number 169. Okay, so let's directly jump into the problem and see what it really is. Now, the problem states that within an array we need to find majority element. And the definition of majority element is that an element which appears more than n by 2 times. That element can be considered as a majority element, right? So within an array, let's take an example. Okay, so within an array I need to find an element which is greater than n by 2. Okay, like the count of that element. So 3, 2, 1, 3, 3, 3, 3. I'm taking a very obvious example. So the number of elements here are 7. So n by 2 is 3, right? If there is an element whose count is greater than this 3, that can be considered as a majority element. So first of all, like majority element is whose count is greater than n by 2. Like this is the definition for majority element. Okay, now this is fine. This is fine. Let me now look at the possible solutions that I can come across. So the very first approach to this problem is very basic, taking pointers and counting the elements. So what I can definitely do is I can run a nested for loop in which for each element I will count the number of elements for like throughout the array, throughout this n elements. I'll run this ith pointer and I'll count each and every element, and after that, after counting number of each and every element, I'll check if that count is greater than n by 2. That is the very basic solution, and but the time complexity is really high, and definitely we wouldn't take it as our solution. We would want a better approach than this. The second approach that I can definitely think of is, and it is kind of better in terms of time complexity, to the approach that I can think of right now is to use something as unordered map, or what you call as hash map, to find count of each and every element. First of all, we can have, like, we can store elements within the hash map, and we can have such key value pairs where key would consist the element and value would consist the count of that element. And after doing this first step, we will move towards the second step, in which what we will be doing is we will iterate throughout the unordered map, and within that unordered map we will obviously, like, the check condition, we will check whether a certain element is greater than n by 2. We will just have to check this condition, and this solution will also, like, this solution will have a time complexity of big O of n, since we will only have two iterations. Yes, the first iteration would be when we are storing elements, and at the second time we will iterate throughout the arrays, which will be equivalent to iterating throughout the array, is like when we will iterate throughout the unordered map. Total time complexity will add up to big O of n, and there will also be space complexity 2, and the space complexity would be big of n because we are storing each and every element with its count, so like more or less it would be big of n. So, but there is another approach to this problem which is in fact better than this approach, and this is a kind of approach in which we need to follow an algorithm. What's the name of this algorithm? It is MOOR. Morse. I don't. It's something like Morse voting algorithm. What we do in this algorithm is that the essential idea of or the intuition of this algorithm is like if we have an array and we have different kind of elements within that array, we are asked if a certain element is greater than n by 2, right? So if a certain element is greater than 1 by 2, if we subtract if a certain element is greater than n by 2, such as in this case, I should delete these unnecessary things right now. Let's have a fresh page. Okay, now we can move forward. So if we take this the earlier example again, we can just see that 3 comes how many times? 3 comes 1 2 3 4 5. 3 comes 5 times. If a certain element is greater than n by 2, that means like the total number of elements is 7. How many elements are left apart from 3? It will be 2. Okay, so there are 2 elements which are other than the majority element. If the total count of this if the total count of majority element is subtracted by the number of elements which are left, it will be smaller than n by 2. It will definitely be smaller than n by 2 because majority element itself is greater than n by 2. So there is no way that the number of elements that are left can eliminate the majority element. There will something will be left out of it. uh, Another way to explain it is, let's take something like stack, and in stack we have 1 2 3 4 5 6 elements, right? If we, let's say, how many elements are the 6, so let's take like 7 elements as in the array. Now the number of majority elements is 5, so the number of numbers other than majority element is 2. If we subtract this, like the number of times the count of majority element, then we will be left with something, right? Something we will be left with its uh, count. This Morse algorithm works on this principle that a certain number is on abundance. So if there is no way that the count of this number will be 0 if we subtract it from the other numbers that are apart from the majority element. This is the entire principle of this MOORE, Morse voting algo. What we do here is we take, let's take that example again, or let's take some a better example. We will take 3 as a majority element and we will fill other elements so on. Let's say 4 6 7 3 3 3 3. Okay, we will take this kind of array. Fine. Now what we are going to do is we will take an element. The first step within this algorithm is to assume assume that the element that you are iterating through is the majority element. And the second part of this algorithm is to like verify whether this majority element is true or not. If the number that I've got is a majority element or not. So this is the case. Now what we will be doing is, let's take element as 3 for example, and its count. We will take count here. So the number of times the 3 appears is initially 1. Now we will go forward. We will see 4. We will see another number is coming. So when so there are certain conditions for count. If another number comes, we will just subtract count with -1, and then we will get 0. We will get our value 0. Let me do it with another pen. Okay, so let's say 1 is here, and then it was subtracted. For subtracting, I'll just use a dash. Now our element will be 4. Now what I'm trying to say is that 4 is my majority element. I'm assuming 4 is my majority element, and now when I'll go further, I will say the count is 1. Now when I'll go further, I'll see that the element has changed. Since subtraction of 1 will lead to 0, what I will be doing is I will change my majority element to 6. And similarly we will proceed. We will change the majority element to 7, and 1 will be changed to 0. Again we will have an initialization of 1 when we are at 7. Again the element will change, so we'll like delete this and we will subtract 1. It will come 0. Now if we count all these now the majority element will change to 3, and the number of count that it has is 4 after a certain number of iterations. At the end, the element that we will have at the end, the element that we will be left with is surely our majority element. We can take different examples, like if you would be thinking that this particular example had all the threes in first, what if these threes were at the beginning, or what if like we just simply reverse this array, would the solutions will still be true through this algorithm? Let's try to do it, and let's see. Let's have another dry run to this problem. Okay, so we'll have a 3 3 3. Let's have a little change. We will have 7 6 3 3 or 2 here. Okay, it's fine. Now similarly, following the algorithm, first we will assume that 3 is the majority element. We will take our element as 3 and we will increase its count to 1. Then it will increase 1 1. For all these iterations, the count will come to as 3, and now we'll subtract when a different element comes. We are not directly taking this element as majority element. We will first see if count is 0. When count is 0, then only we will change our majority element. So now we will subtract, because 7 is coming, we'll subtract it by 1, it will become 2, and then 6 is coming, so we'll subtract it by 1 again, it will come 1, and when 2 comes, we'll just subtract it again and it will come 0. So when this happens, we are again at the condition where we will have to change our majority element. So when this happens, we are taking 3, the next element is 3. So of course how are we going to change 3 to 3? Now our majority element is 3, and we will increase its count, and it's too obvious, the count will go up to 2, and the final answer which we get after this algorithm is 3, regardless of how the array has been rotated or manipulated. So now let me just implement this algorithm and see if it works. So first of all, we'll be taking element as -1 as the default element, since all the numbers are positive here as per the constraints. Yeah, as per the no, there are negative numbers too. Okay, like let us take it as a default case. I feel it will obviously update. Let me take it as int ma int men. Okay, it's fine. Int count equals 0. Now what we're gonna do is we will iterate through the array. Yes, now we will be having certain conditions, certain cases. This will be our case first, where if count is exactly equals to 0, what we will do is we will update our element to whatever number is there, nums of I, and we will increase our count. What else are we gonna do? Are we gonna do something else? Let's see. If the number is 0, the count is 0, we'll change the element and we'll add 1. Okay, it's fine. We will add the number of time it comes. So else if the second condition will be here, which is if nums of I is not equal to element. If it is not equal to the element, we will do count minus minus, and for any other situation we will do count plus plus. Or if it is exactly equals to element, we can do a count plus plus, and in any other situation we will have count subtracted by 1. Now the only thing is to return element. Okay, there's a little error. Okay, so my solution is running for these two test cases. Let's see if it works for every other test case. Yes, my solution is running and it beats 100%, so it's fine. So this is our algorithm, and Morse voting algorithm. And thank you guys for watching my video, and thank you for supporting me. It means a lot. Okay, let's log out.